Now, the simplest way of analyzing forces is talking about collinear forces, means all the forces are perpendicular or on the same plane or on the same axis. Collinear forces can be added and subtracted based on the problem, as we learned in the vector section previously. So you have here an object or a cart being pulled 30 newtons to the right and being pulled as well 10 newtons to the left. Then you need here to add the collinear forces. But before we do that, when we create a free body diagram, many cases we have a problem that there is a rope pulling this cart, let's say, or there is a bucket being hanged with a rope. You need to be able to remove that rope and draw a free body diagram and replace it with a force. There is certain assumptions that you need to use to be able to solve these problems without many complication. Firstly, the mass of the rope is negligible. The rope has a mass, but we neglect it for the ease of solving the problem and not making it very complicated. The tension is uniform throughout the length of the rope. That's the second thing. The rope has negligible thickness. Ft or F thickness act parallel to the rope as it directed away from the object to which the rope is attached. The rope is taut and does not stretch. That means that the rope doesn't increase and decrease in length. His length is constant. Any object attached to the rope will have the same magnitude of acceleration as the rope. These things keep in mind. Those would help you in solving problems coming up about how to analyze forces and draw your free body diagrams. Here we have two people, A and B, are dragging a canoe out of a lake onto a beach using light ropes. Each person applies a force of 60 Newton forward on the rope. The force of friction exerted by the beach on the canoe is 85 newtons backward. And starting with a free body diagram, calculate the net force on the canoe. That's the canoe. We have two people pulling the canoe out of water to the beach, and there is a friction force as well going backwards as 85 newtons being applied on the boat backwards. You need to find the resultant force or the net force. Firstly, Ft1 is the tension by person A, is 60 Newton forward this way. We say forward is positive, backward is negative in this case. And we can see all the forces here are being collinear, means on the same plane. There's no angles over here, so we just have forward and backward. That make it easy for us. We have Ft2, the tension from person B is 60 Newton forward as well. Friction force 85 Newtons backward that way. What you need, F net or F resultant. Then first you draw a free body diagram for the boat. You put the boat in here, draw a dot in the center of the boat, friction to the left. You draw it again here, Ft1, Ft2, and F friction here. We said we draw a resultant force vector from the tail of the first to the head of the last. That would be this F net. Either you solve it graphically if you draw to scale, or you solve it by numbers. In this case, we know F net is Ft1 plus Ft2 minus F friction, as you can see, or you combine them all. F friction by direction is minus. That would give you 60 plus 60 minus 85 Newton would give you 35 Newtons forward for the resultant force.